Good day, students. So welcome to the Integrated Algebra Regents review for June 2013. This is going to be a high-speed review clip from questions 1 through 30. It's meant for students who have a solid mastery and just want to do a real quick refresher of the content on this test. Also, is meant for advanced students. Now, if you want a detailed step-by-step explanation of each step and see me work it out, go to mathgoserve.com/test-prep, and then you see me work it in chunks of 5 problems each, okay? So this is just a high-speed review session. All right, let's take a look at question 1. We asked to write 5 less than twice x in algebraic form. So you just basically reverse the order and you write twice x, 2x minus 5, and you can see that the answer is option number 1. Question 2 is probability. You have these number of different denominations of coins. 6 coins were taken out, 6 quarters were taken out, and it resulted in you having 14 quarters, 15 dimes, 7 nickels, and 8 pennies. You were asked to find the probability of selecting a quarter after the removal. The formula uses number desired over total. So the number desired is 20 minus 6, which is 14, because you took out 4 out of your 20 quarters, so you have 14 divided by the total. Since you took out 6, the total drops by 4. So if you add all this together, 14 plus 15 plus 7 plus 8, you get 44. So the number of quarters, which is 14, divided by the total number of coins, which is 44, gives you the probability of selecting a quarter after taking out 6 quarters. Question 3, you're asked to find the output for June 2015. All you do is you start from June 2015, draw a straight line to the line, positive linear correlation, and then you trace it to the output. The number next to 500, above 400, the best option is 480. Okay, so that goes your output. So for question 4, you asked to find if 5k lies on a point, then what's the value of k? So the point, any point that lies on a line, if you plug it into this equation, you're going to have a true statement. So all you do is plug in 5 and k into this equation, 5 for x, k for y, and you have 2 times 5 plus k equals 9. You solve it using the procedures of algebra, and you end up with k equals -1. In problem 5, you're changing 5.5 gallons into ounces by using this conversion chart right here. First of all, you change it into mixed numbers because it's easy to multiply and reduce. So 11 over 12 gallons. So you just basically set up your conversion factors in such a way that the gallons cancel out and the quarts cancel out, and you're left with ounces. Okay, so when you're setting up your ratio for quarts and gallons, since you already have gallons and 1 gallon is gone, you put 4 quarts over 1 gallon, quarts over gallon. This changes gallons to quarts because the gallons cancel out. And then for the ounces component, since you want the quart to get canceled out, you put the 1 quart on the bottom and the 32 ounces on the top. And you put your respective conversion factors, 4 over 1, 32 over 1, 11 over 2. Cross out the units. You must be left with the desired unit, which is ounces, as you can see here. Simplify these numbers. 2 goes here, 1, 2 goes here, 2. 11 times 2 times 32 is 11 times 64. 704 ounces are what you have in 5.5 gallons. In question number 6, you're given a graph of a quadratic equation, and you're asked which of the following represents the roots. So basically, wherever this graph cuts the x-axis, that's the roots. It cuts the x-axis at -1 and +4. Those are your roots. Do not include this. This is not your roots. It's your y-intercept, okay? So just -1 and 4 are your answers. All right, in problem 7, you're given the area of a rectangle in a polynomial expression. You're given the length of one side, and you have to find the length of the other side, the width. So basically, the 2 ways you can do this. You can either factor this out, something like this. You're using the x game. You notice that one of the factors represents the length, and the width is the other factor, x plus 3. Another way you can do this is you take the area polynomial and divide it by the length, which is x plus 5, using long division of polynomials. You divide it out, and you have x plus 3, and that represents the width of your rectangle. For question 8, we asked which of the following represents a qualitative data. We know that qualitative data is something you cannot put a number on. You basically describe it using words. And if you look at all these right here, weights involves numbers, heights involve numbers, shoe size involve numbers, colors is the only quality that you cannot quantify using numbers, so that's a qualitative measure. In question number 9 is just an assessment of your ability to compute factorials. This is a long expression, so you can use a calculator to do it. So let me go ahead and show you how to do this using calculator. Um, so in order to avoid error by grouping, it's good to break it down. You do each term individually first, and then you combine your final result. Okay, so I'm going to do 6 factorial first. The two ways you can get factorial, either in the catalog or in the math menu. I'm going to get it from the math menu, so you press math, and you go to probability tab. Under that, item number 4 is your factorial. 6 factorial is 720, write it down. Next to evaluate is 5 factorial times 3 factorial over 4 factorial. So we have, let's do that. Parenthesis 5, math probability 4 gives me a factorial times 3. Math probability 4, that gives me factorial again, divided by 4 factorial. Math probability 4. Enter, you get 30. Now to finish it up, we're just going to do 720, which represents 6 factorial, minus 30, which represents 5 factorial times 3 factorial over 4 factorial, minus 10, and final answer is 600 and, wait a minute, let me mistake, 720, oh, plus. So 720 plus 30 minus 10, and 740 is your final answer. Okay? All right, question 10. We're given an inequality notation and asked to change it into, you're given an interval notation. You're asked to change it into a set notation. This could be considered an inequality notation too. So all you need to remember is when you have a line under the inequality, it's a bracket. That means that the endpoints are included. If you don't have a line, it's parentheses. You have lines in both of them. So that means you're going to use brackets twice from -3 all the way to 3. So your answer is question, option 1. Number 11, you're given solutions to a quadratic equation, and you ask which one work, which of them are correct answers. There are two ways you can do this. You can just plug in the answers and see which one work. As you can see here, I tested one in the option number -2. -2 didn't work. So that means that option 1 is not correct. And then I tested 2 and it worked for option 2, and I tested 14 from option 2 and that worked. Since both of the answers work, that means that our correct answer is 2. That's the method of plugging and checking. Another way you can do it is simply put this quadratic in standard form and factor it, and use the zero product property to solve. You end up with 2 and 14. And there you have it. So whichever method you like, you can plug and chug, or you can just simply factor. You get option 2 as your final result. In question number 12, we are asked to find the value of a that makes these two expressions equivalent. So since they're going to be equivalent, you set them equal to each other. Use the properties of exponents. You distribute the 4 to the powers. 2 to the 4 is 16, divide both sides by 16. Remember, your goal is to get a by itself. Okay, so when you divide both sides by 16, you have y to the 4a equals y to the 8. Now, since the bases are the same, you can just drop the bases and equate the exponents. You have 4a equals 8, divide both sides by 4. Your final answer is a equals 2. In question number 13, you're given 4 sets of data, and you're asked which one is bivariate. Bivariate basically means that the data are connected, or you have an independent-dependent situation. They are connected in some way. Univariate data are data sets that are not connected directly in any shape, form, or fashion. Okay, so if you look at these 4 sets of data, age and frequency, there isn't any direct correlation here. Time spent studying and test grade, there is a correlation, because the more time you spend studying, ideally, the higher your test grade should be. If you look at the other options, types of car and gas mileage, there isn't a direct correlation. It depends greatly on probably the size of the engine and the kind of car that you're driving. So size of engine is definitely directly correlated with gas mileage, because the bigger the engine, the more gas it uses. But just the type of car is not a direct correlation. So this is univariate. Days and temperature, the day of the week doesn't tell you anything about the temperature. So this is univariate because there isn't a direct dependent and independent relationship. So the only bivariate data set here is time spent studying and test grade, because they're dependent on each other. Your test grade is dependent on how much studying you do. So you have a bivariate data for option number 3. In question 14, you're asked for what do 65, 85, and 100 represent in your box and whisker plot. 65 is right here, 85 is right here, and this is 100. So if we label it correctly, 65 represents the first quartile. This is the second quartile of the median, and this is the third quartile. That's the max, and this is the mean. So 65 corresponds to Q1, 85 corresponds to Q3, and 100 corresponds to maximum. So Q1, Q3, and maximum are the what these scores represent. In question number 15, you ask what value of x makes this expression undefined. Basically, set the denominator to 0 because whenever you divide by 0, you have an undefined output. So if you set the denominator to 0 and solve using properties of equality, you have x equals -2, so your answer is negative, is option 1. And question 16, you're asked to solve for x, what expression represents x, so basically solve for x. So you treat this like an equation where you want to get x isolated, you get rid of negative st. From the left side by adding st, and then you finally divide by both sides by r to get x isolated. So r plus st over r represents x, so your answer is option number 1. In number 17, there are two ways you can do this. You can plug and chug like we did before, or we can solve. So I solved this rational equation. What I did first is cross multiply both sides. You have x times x plus 2 equals 8, 2 times 4. And then if you distribute, you have a quadratic equation. If you want to solve by factoring, you have to put it in standard form. So I subtracted 8 from both sides. So we have x squared plus 2x minus 8 equals 0. So to solve this, just use the x game. You have a factored form. Use the zero product property to set each factor to 0. And you solve for x using properties of equality. -4 and 2 are your answers for question 17. Remember, you can always plug and chug here to see which one works, and as long as both solutions work, that should be your correct answer. In question 18, you're asked what is the function which is represented here. You just need to remember what your different functions look like. A linear function is always a straight line. This is not a straight line, so it can be option 1. Quadratic function is a u facing up or down. That's definitely not the case here. Exponential is a function that starts growing slowly and then it picks up to a higher rate. That's exactly what we have here. So this is an exponential function. An absolute value function is a v opening up or down. So basically, memorizing how your graphs look like for each family of functions will greatly aid you in answering this question. All right, in question 19, you're asked to find which represents what is the slope of the line represented by this equation. There are two ways you can do it. If you want to use the standard formula, is negative a over b. So a is 4, b is 3, so negative a over b, which is the slope, is -4/3. Or method 2, you can convert this into slope-intercept form. Subtract 4x from both sides and divide by 3. You have y equals -4 over 3x plus 4. And then the coefficient of x is your slope, so the coefficient here is -4 over 3, so there goes your slope. In question 20, you're asked which of the following equations represents this line. You just need to remember that less than means you shade the bottom, and when the line is solid, you have to have a line under your inequality to indicate that the line is part of the solution region. Since this line is solid, we can definitely eliminate option 1 and 3 because there are no lines under the inequality. Now, since the underneath of the line is being shaded, we can conclude that less than is your correct answer. So y less than or equal to x minus 1 is your correct answer for this, okay? In question 21, Jan basically, Carl has sold twice as much subscriptions as Jan, and the total subscription is at least 90. So we have to determine an equation that can be used to, an inequality that can be used to solve for the number of subscriptions Jan sold. So basically, if Carl sold twice as much as Jan, we'll let Jan be the independent variable x, and then Carl will be defined in terms of Jan, which would be 2x. Since it's at least means either that value or greater, so greater than or equal to will be our inequality that represents the relationship here. So you put them together, the sum, x plus 2x has to be greater than or equal to 90. Using the commutative property of equality, we can express x plus 2x as 2x plus x greater than or equal to 90. So you can clearly see that option 4 is our answer here. For question 22, we are asked what is the result when this polynomial expression is subtracted from this one. So you basically write it in a reverse order. This goes first, and you subtract the second from it. Distribute minus to the second polynomial, which switches all the signs. You combine downwards. You have 2x squared minus 2x. As the final answer, option 1 is your answer. In 23, you're asked to find how many hours there are in W weeks and D days. So basically, you find a relationship between the number of hours in a day and also the number of hours in a week. Since you have 24 hours in a day, you're going to have 24 D hours in D days. There are 7 days in a week. If you have 24 hours in a day, that means you have 7 times 24 hours in a week. All right, so if you have 168 hours in a week by multiplying 7 by 24, then in W weeks, you simply have 168 W week hours in W weeks, since you have 168 hours in 1 week. So the total number of hours is basically the sum of these two expressions, 24D hours in a day, in W days, in D days, sorry, and 168 W hours in W weeks. So the sum is 168W plus 24D. All right, so in 24, you have to find out what is R intersect P. So basically, what are the elements and sets, what are the elements that are common in both sets R and P? So what you do is you list the sets on top of each other, line them up so that only like elements of the sets are aligned, and then you basically group the sets that are present, the elements that are present in each set. In this case, only 1 and 3 are present in both sets, so R intersect P is 1, 3. 25 is right triangle trick. We ask for which ratio actually represents the measure of angle D. So basically label the triangle relative to D. Since this is D, the side opposite is opposite. The side opposite is a 90-degree angle is hypotenuse, and this is adjacent. So if you compute sine D using SOHCAHTOA, it's opposite of hypotenuse, which is 12 over 13. So sine D equals 12 over 13. That's the only accurate option here. The other options will result in 5 over 13 for cosine, which is not here, and 12 over 5 for tan. Tan is not even an option. So the correct answer is 12 over 13 using SOHCAHTOA for sine. In question 26, we're given two roots of a quadratic, and we're asked which equation would generate those roots. So it's basically working backwards from the zero product property. We set x equals to both roots, and we get both of the equations equal to 0. And the reverse of the zero product property, we have the factors be multiplied by each other, x plus 2 and x minus 3 equals 0. As the equation generating these results, so our final answer is x plus 2 times x minus 3. In question 27, we're given a line that's parallel to the y-axis and goes through 4, 3, and we have to write an equation of the line. So you just need to remember that every line parallel to the y-axis is a vertical line, and the vertical lines have undefined slopes, and they are of the form x equals, because they always assume that it's constant x value regardless of the value of y. As you can see here, x is constantly 4, 4, 4, 4, 4. And so the answer to this is x equals 4 because it's a vertical line that goes through 4 on the x-axis. In question 28, we are selecting 3 students to be placed in 3 positions out of 18, and the question is a permutation or combination. Combination involves choice. There's no order of placement involved. Permutation involves placement or ordering elements of a set. In this case, we're placing 3 students out of 18 into 3 spots, namely the leader, recorder, and timekeeper position. So this is going to be a placement problem. So it's going to be permutation. So we're just going to compute 18 P3 as your choice here. So in order to compute 18P3, 18 plus 3, you can use your calculator or do it manually. Since you can use your calculator here, but you might as well go ahead and use it. So I'm using a TI-83. You're going to go 18. And then you can go to catalog to look for NPR since you're using permutation. Second function 0 will take you to the catalog, and then scroll. Let's use n. I'm going to type n. This is combination right here. That's not what we want. To scroll down a little bit more. NPR, that's permutation. 18 place 3. Enter. Final answer is 4,896. Question 29 involves the Pythagorean theorem. We're dealing with a right triangle. RST, the right angle is basically R, so you have to make sure when drawing a triangle, R is assigned to the right angle, and S and T doesn't really matter. And then you label your triangle using these measures, 6 for TR and an 8 for TS. You have to find RS, so the relationship between 3 sides is A squared plus B squared equals C squared, where C is the hypotenuse or the longest side of your right triangle. So you set it up like this using the Pythagorean theorem, plug in the values, and solve for B. B is equal to root 28. All the options here are completely simplified, so you simplify a radical, break it down. 2 2's repeat, so they come out as 1. 7 stays behind, so 2 root 7 is your final answer here. And then for question 30, you ask how many solutions are there for this system of equations. You have a quadratic and a linear. So as you can see here, you can either have 2 solutions where the line cuts the parabola twice, or 1 point of tangency, or it doesn't cut at all. So there are 2 ways you can do this. You can either grab these in your graphing calculator and examine how the solutions look like, or you can do it algebraically. I did it algebraically here by setting both equations equal to each other. And then since it's a quadratic, I have to put it in standard form before solving it by factoring. So I set equal to 0 by subtracting x plus 6 and adding 6 to both sides. We have this quadratic equation right here. factor by grouping. Use the zero product property to solve. We notice we have a double root here. X minus 3 equals 0. X equals 3 is the answer we have. So how many distinct solutions do we have? We have exactly one. So our final answer is basically 1. So if you want to do this by graphing, let me show you how to do that. All you do is you enter the equations in your graph. You press the Y option. And then we're going to enter x squared minus 5x plus 3 for the first one, and then x minus 6. Enter graph. So the question is, how many times does this line intersect the parabola? It intersects exactly once. You can zoom in to be certain. Let's go back. All right, so let's zoom in around that point of intersection to help you see that it actually intersects once. If it intersects more than once, that means that you have more than one solution. Remember, we're not looking for the value of intersection here, we're looking for the number of intersections here. So we have only one point, though, that point of tangency here. And you can even calculate what intersection is. Second function calculate, 5, option 5. First curve, second curve, guess. Just go put the cursor around where the intersection is. If there's more than one intersection here, the calculator won't be able to compute it, but if there's exactly once, it will give you what the answer is. So press enter. Boom. There's only one intersection here at -3 and 3. I mean at 3 and -3. So we have only one intersection, hence we have one solution. Alright, so there you have it. So thanks so much for taking the time to watch this presentation. Please feel free to subscribe to my channel by clicking up here. And please post a comment to let me know what you think about this presentation. More clips come up on microserve.com/testprep, where you can just scan this code right here. Remember, this is the high-speed review session. If you want to go over the step-by-step computation of each problem, just go to microserve.com/testprep under New York Regents, and there you see it broken down into about 6 review series. So thanks again for watching, and have a wonderful day.